Hello, my name is Mitchell Parros and today I will be talking about hydrogen cyanide. Hydrogen cyanide, also known as formonotriol, is a molecule comprised of one of each of the following elements: hydrogen, carbon, and nitrogen. According to Encyclopedia Britannica, it was discovered in 1782 by Swedish chemist Carl Wilhelm Scheele and was originally used in the colour Prussian blue. Hydrogen cyanide has been used for a wide variety of purposes. However, the most infamous use of the molecule is by the Third Reich when they used the gas to commit genocide. The inhalation of hydrogen cyanide and the effects on the body is what I will explain to you. Now, I had four of my great uncles that fought firstly in Europe against the Nazi regime and then against the Japanese Empire in the Pacific. Thus, I have a strong connection to the molecule via my relatives. Hydrogen cyanide is a colourless or pale blue liquid below 25.6 degrees Celsius and a colourless gas above it. Although hydrogen cyanide has a distinctive bitter almond odour, not many people can recognise this, thus odour cannot be used to reliably detect the molecule. According to Centers for Disease Control Prevention, hydrogen cyanide is described as a systemic chemical asphyxiant, and exposure to the gas is often rapidly fatal as it can affect the cardiovascular system, the central nervous system, and the pulmonary system. In this molecule, carbon is a central atom and hydrogen shares a single bond with it, whilst nitrogen is triple bonded to the carbon atom as shown by my molecule. As you can see, these bonds are linear, however electronegativity plays an important role in the deadliness of the molecule. A nitrogen atom has an electronegativity of 3.04 Pauling units, whilst hydrogen has an electronegativity of 2.2 Pauling units. Thus, there is a difference in electronegativity of 0.84 Pauling units, and as this electronegativity delta is much greater than 0.4, there is a strong polar bond in the molecule. Therefore, the hydrogen side of the molecule will have an overall positive charge, whilst the nitrogen side will have an overall negative charge due to the concentration of electrons. Now, in the human body, there are a large number of compounds and molecules, so it is very easy for the hydrogen atom to be stolen by a compound with a higher electronegativity. With the hydrogen atom gone, the molecule becomes a negatively charged cyanide ion. In this state, the cyanide ion becomes a competitive inhibitor, much like carbon monoxide. Within a cell's mitochondria, the cytochrome C oxidase enzyme is the vital catalyst in producing energy for the cell to sustain itself. Once a cyanide ion enters the mitochondria, it actively competes with oxygen cells in order to bind to an iron atom in the enzyme. If the oxygen cell is bound, energy is produced. However, if the cyanide ion is bound, no energy will be produced and the cell will die. Now, if this occurs on a large scale, it is very likely that one can die extremely quickly. Now, I hope you have found my explanation of hydrogen cyanide interesting, and thank you for listening.